Okay, the next question says, determine the equation of g if you are given this, the derivative of g. Okay, well, when I did this, I thought this is kind of weird because I can see like the only way for the derivative to be 12 here would be as if that was 12x. So it's a little bit strange. I'd be finding that, I can just write down the answer, and that's kind of what I did. But they're looking for something a little bit more systematic. Using algebra to do it, this is how you do it. There's g of x. They gave that to us, ax cubed plus bx squared plus cx. The derivative, just do it with the a's in it, 3ax squared, 2bx plus c. But we know that that equals minus 6x squared plus 6x plus 12. Well, then just compare the places. 3a must equal minus 6. Look, it's in the same place. The coefficient of x is 6. 2b and 6 must be equal. And c must equal 12. Well, there we've got it. A is minus 2, b is 3, and c is 12. And that's your answer. When I looked at it, I kind of thought that's the only thing it could be and just wrote down the answer. But that maybe is not so great. So that's how they wanted you to do it. Okay, let's take a look at this last question. Determine question 8 here. Determine the equation of the tangent to g that has the maximum gradient. Well, they just say, well, the maximum gradient happens at the inflection point, a half here that we figured out before. That's okay, but why is that? I don't know. Here's one way to do it. You've got the derivative. What's the maximum value of this? Well, it would happen at minus b over 2a. This is an unhappy parabola, this equation. And minus b over 2a gives me, oh, the maximum will occur at a half. So let's put that into the derivative formula. Let's put a half in and see what number we get. Well, that's a pretty important thing. It says determine the equation of the tangent to g that has the maximum gradient. Okay, we're looking for the line that will have a gradient of 27 over 2, the maximum gradient. Well, it's y equals 27 over 2x plus some number c. All we're missing, we've got the x value, we've got the gradient, we need the y value. So we put a half back into the original function, and we get 13 over 2. Now we've got an x value of a half, a y value of 13 over 2, or 6.5, and all we do is use that formula for the gradient and a point, which is x is a half, y1 is 6.5. Just put that in. The gradient is 27 over 2, or 13.5, and then just work it out. 13.5 times x, there it is, 13.5x. 13 and a half times 5 minus 6 and a half. And what do you get? Maybe on your calculator, you get minus a quarter, minus 0.25. There's the equation of the line that's tangent right at that point of a half. That's its gradient. And this is the equation of the line that passes right through that point, right there, where the gradient is the most, maximum. Okay?